So we have a broom here, and you can see I have it balanced at its exact center of mass, almost. It's a little bit tipsy, but it's hard to get it to balance exactly. So the question I'm going to answer is, if you were to cut this broom exactly here at its center of mass, or at its center of gravity, which side would be heavier if you were to weigh both sides? The answer is that this side would be heavier with the wispy part of the broom, and I'll explain why in a second. So we're basically going to repeat this experiment, but with this on a smaller scale. So we have this pencil here, and let me get it all set up. I've got a little weight on the edge here, just this little carabiner, and you can see that it's balanced similarly to the broom. We're going to cut this pencil in half and weigh each side, and we'll see which one weighs more. Okay, I've got a little kitchen scale here, and we're going to weigh both these halves. As you can see, I cut them in half here. First we weigh the side that had this little carabiner on it, and it weighs 0.2 ounces. And we'll put this one on there, make sure it's zeroed out. You can see that this weighs 0.1 ounces, so this side weighed more than this one. Looking at these two halves, you may assume that they should weigh the same, because when balanced out, as we saw earlier, their center of gravity was here. It seems like logically they would weigh the same, but they don't, and it's because weight is different than force. And the reason why these two needed to be different weights is because the force on both sides was different, and forces needed to be the same in order for the center of gravity to be balanced out.